In this video we are going to be covering distance time graphs and in particular being able to interpret them. We're going to be looking at what different parts of a distance time graph means, and on the tail end of this video we will also be building a story as well from a distance time graph. So what is a distance time graph? It is a graph that plots the distance an object or a person travels against the time it takes to travel. It is a straight line graph, but there are different parts to it. So the first thing we're going to do is look at the different types of lines you get on distance time graphs. So at part A we have a steep line, and this steepness indicates that the object is moving constantly. Now part B shows a completely horizontal line, and that signifies that nobody's moving, or this person has stopped or is at a break at some point. Now part C shows a line just like A, which is slightly less steep, and so that indicates a constant rate but slower. So the steeper the line, the faster an object is moving. So to recap, this is how distance, speed and time all relate to each other. So speed is distance over time, and distance is speed times time. So we're going to practice using that first before we do anything else. So using this triangle, example 1. So we have the distance of 150 miles, the time of 2 hours. To find speed, you do distance divided by time. And the speed will be in miles per hour, because that's what the units were for distance and for time. In example 2, this time the time is in minutes, and to use this triangle time has to be in hours. So 30 minutes is the same as 0.5 hours, or half an hour. So to find the speed, we're going to do the distance divided by the time. So it's going to be 80 divided by 0.5. Finally, in example 3, we have the speed of 18 kilometers per hour. We have a time of 3. To find the distance, it's just speed times time. So 18 times 3, and your units are going to be in kilometers. So that's how you use the distance, speed and time triangle. Now we're going to use that to answer the following. So the following distance time graph shows a car journey. How far did the car travel in the first 3 seconds? So if you go to the time, which is on the x-axis, at 3 go up and across, and our distance is 60 meters. Part B, how long was the car stationary? Now stationary means not moving, and that's indicated by the completely horizontal line, and so measuring that, it's just 2 seconds. Now for part C, what was the car's greatest speed? So the steepest part is this area here. So if we look at the distance, which is 100 between the top and the bottom of that line, the time is 2, so looking at the width. So to find speed, you do distance over time. Note that it was actually the height divided by the width of the triangle, and that was 50 meters per second. So Sam cycles from his home to the park and back. How long does it take Sam to reach the park? He reaches the park at that point before the stationary line. So he reaches the park in 30 minutes. Part B, how long did Sam spend at the park? So that's the length of the stationary line. So measure that via the time axis, and that's going to be 45 minutes. Part C, what was Sam's speed on his return home? So again, you want to tuck in that little triangle, and then it's going to be the height divided by the width. Now the height is 4.5 and the width is 25 minutes. So the distance was 4.5 miles. The time, 25 minutes. We need to work out what 25 minutes is in terms of hours. Now remember, a full hour is 60 minutes. So it's going to be 25 out of 60 as a fraction. You don't have to simplify that. So the speed is just 4.5 divided by 25 over 60, which is 10.8 miles per hour. D, what was the total distance? That's going to the park and travelling back. So going to the park it was 4.5 miles, returning was also 4.5 miles, so 4.5 add 4.5 gives a total of 9 miles. Now example 3 is going to be the final thing of this video, and that is just describing what is going on in a distance time graph. So I've made up a name. So Emma leaves home at 7. Now if you look at the first initial change between the steepness, it's in the first 15 minutes, and in 15 minutes it's 1 mile, so per hour it's going to be 60 minutes, which is timesing it by 4, so she has to walk at a speed of 4 miles per hour for 15. If it's 1 mile per 15 per hour, it's going to be 4 miles. She then increases her speed to 8 miles per hour for a further 45 minutes. And then we've got the stationary line, so she must have taken some form of a break, so she stops for half an hour and then finally returns home at 9:45. And that's it.